So I'll wait about another 30 seconds or so, and we're going to start this tech talk. We will start off with a short video showing our plant in Miami, where we manufacture all these different types of cables for audio and video and broadcast. You see some of the equipment that we use to produce these things. And then I will turn the presentation over to Danny Ritz, our VP of Engineering, a wealth of knowledge, has a solution to almost every problem that anyone has ever come up with so far. And we'd like to open it up to any of your questions. We'll show you some of the practical aspects of dealing with 12G cables and connectors in the broadcast and AV environment. And we'd sure like to hear from you with any of your comments, your questions, maybe some experiences that you've had on some projects that may be of help to all the rest of us. So with that, I will start our presentation. Welcome to our plant. It's our Brazil office. And there is a 12-pair audio cable going into DT12 connectors. Teflon insulators. Planetary cabler we use for SMPTE fiber cables. And braiding. Final extrusion. SMPTE termination, don't try that at home. And that is our plant. We'd welcome any of you for a tour next time you come to Miami. So I will now turn over the presentation to Danny Ritz. And again, please make the most of this, take advantage of it, and please share your questions and comments with us. Danny?
Morning, everybody. Give me a moment to get my video up here. This is my face, but we're mostly going to look at my hands and do a bit of show and tell. I'd like to discuss why we're talking about coax, because this, move into the 6 gig, 12 gig arena, and everybody's scratching their head about what does that all mean. We barely got the 1.5 and the 3G down, and now we're at 6G and 12G, and that 12G was a bit of a step. What exactly has changed? Will my infrastructure support it? The answer is yes, no, and maybe. Historically, coax has always followed telecommunication. I say this mostly because we are not the trendsetter. We don't normally invent things. Broadcast normally doesn't. We basically follow. Historically, telecommunications invented coax. They implemented coax. We borrowed SDI from DS3. The original AT&T 735 actually became our AT&T, or like Belden 1855. AT&T 734 became our RG59, our first SDI. So all of our protocols for copper follow telecommunications. And the designs and implementation of it should, it should be obvious that if we just look where telecommunications is going, that's where we're going to go with copper. But right now, we're in this move towards this 12G protocol. If any of you are RF people, meaning original satellite, broadband transmitters, you're a 50 ohm guru. That's pretty much where my world was. I'm an RF person. I love the array of RF coaxes, and trust me, in the world of 50 ohm, there are 100 times more coaxes available for us. Is precision in machining. I'm going to show you some things about connectors and mention how they've changed a little bit. But I think that the number one change that has actually occurred in the world of 6G and 12G is our ability to test it. I saw data reports years ago on 12G BNCs. There was no such thing as a 12G BNC. Nobody had actually made any major changes. It was our ability to test it. It was people experimenting, 5-6 years ago with test equipment to actually have the ability to test in a 75 ohm format across a range of frequencies and as high as 12 gigahertz. We actually didn't even have 6 gigahertz a few years back. And now actually people can afford them. Now they're in the 30K range. It sounds like a lot for test equipment, but they were in the hundreds of K originally. But now that we have the ability to test them, we can say something about them, whereas before we could only infer something. We could, proof in application, but not proof in testing. So the things that have changed in the RF aspect of coax and in machining of this is literally the tolerances and application. We're making something true at a 75 ohm. Historically, we were nominal 75 ohm. That means plus or minus L10. Then we were plus or minus 5, then we were plus or minus 1. And we're pretty much going to hold to that plus or minus 1. So I'm going to show you some things, take away from my face and point some stuff down and talk about connectors. And I've got some samples here. They're not the end all. I don't presume to have all of the options here. I just have some that I'd like to discuss and explain how in a quick glance you can actually tell the difference. Real quick, this is a well-precision machined connector. It follows a telecom format. It actually is a Neutrik connector. It's a Neutrik BNC. Most people are not familiar with Neutrik BNCs. Neutrik's more known for an audio world. I'm going to compare that quickly side by side to a Canare. And everybody's familiar with Canare because they make very pretty stuff. They have the larger knurl, which is very popular for people, especially our remote people, for the ability to reach in and grab them. So what has changed inside is the internals. These are much more precise and precision engineered, maintaining much closer tolerances. So we're basically trying to develop a connector that is transmission line, almost invisible. So it doesn't look like an impedance bump. But how do you tell from the outside? Well, I can't say that Canare's really done an exterior job to the connector. Both their medium and their full-size connectors basically still look the same. The Neutrik actually has changed the plating on the connector. They've actually coined a term called antraloy. But you see this dark? This isn't black. It's sort of a gray finish. This is their designated 12G. Along the lines of, is there a big difference in it? Again, precision tolerances, redefining tolerances, holding closer tolerances. So it also appears in their receptacle world. We're real big on black and gold, and in the Neutrik world, we often see black connectors. But this funny off-gray, near-gray plating, this antraloy, that is a designation for their 12G world. You're not really seeing that in the Canare world or anybody else's world. So here they've clearly defined the difference. Internally, no. I mean, my inspection is telling me that these two are very much alike, but I think that this is basically saying this is the future or this is more precise. Not a big monetary difference either. So you don't want to be responsible for speccing in something in the first question out of, are they 12G? And then they can go show you on paper that you didn't spec a 12G. Do I believe there's a big mechanical difference in these two particular connectors? No. but you don't want to be left holding the bag if there's a problem by having something that's not 12G in a 12G scenario. The other neat thing I'd like to show you about the Neutrik that I'm a big fan of is the fact that Neutrik comes with a small rubber boot that snaps on. Not to say the Canare doesn't come with a rubber boot. The Canares are famous for their rubber boots, like the old King's boots. But in this case, this rubber boot snaps onto the back and is available in a wide range of colors, which I'm a big fan of. In addition to that, the connector, after you snap this up, actually allows the boot to snap up and grab the back of the connector. I've already got one fully assembled here. So what that means to you is you actually can rotate the BNC just by rotating the boot. The boot is attached to the connector, not attached to the cable. It's actually just your dust area, color coding ability, adds to strain relief. So there is an advantage to that. The Canare is wonderful in the fact that it uses a rubber boot, and they're also color coded. But the advantage to the is that it's now making up for that shorter knurl nut that we used to worry about, coupling and uncoupling to a recessed connector body. With our big girl fingers, it was often difficult to get in there and get a hold of them. Now we have the ability to mate and unmate those BNCs by simply coupling the back nut. Which we were always able to do with the Canare easily. You got Canare fans, you got Neutrik fans. Now, along the lines of cable, Belden revamped their entire 3G, 6G, 4.5G line. They printed this stuff based upon their means to test it. I know I was on the forums with the Belden engineers as they were getting their test equipment and printing it. And we had 3G cable, 4.5G cable, with 6G cable. What changed in those designs up to 6G? Nothing, only our ability to test it. That was the echo that I was getting. So in the Belden world, basically we had our three main components, our 1855s, our 1505s, our 1694s. Real smart on their part. Just change the first digit to 4. Why 4? I don't know, but 4855, 4505, 4694. That'll get you your basic three pluses, 3 sizes. The other thing that has changed, besides the part number and the ability just to change the 1 to a 4, Belden chose an old route that was very popular in the RF world, and they've actually bonded the foil, which originally was always supposed to be bonded in the designs. Belden had a Z fold. You can tell I'm a book nerd when it comes to that, versus a true bonding. This foil is bonded. In other words, you don't get to peel it. It doesn't fall off anymore. That alfoil is actually stuck to the poly. The other thing here is they've coated the center conductor. It's silver plated now. Now that is an old school trick we used in the RF world to flatten the curve out at higher frequencies, improve the VSWR, and basically make the performance a little more linear at higher frequencies. Also in the analog high frequency world of component video, we also did that. Now, the other approach is to basically improve shielding. If we can't improve conductivity too much, size too much, there hasn't been a revolution in insulators. We've improved the velocity, lowered the loss a little bit, but let's say nominal, we're still 83 to 85%, because after 85%, this core, this foam core gets too soft, so it will collapse. And the last thing you want is something that does this and actually causes a massive impedance bump. So you don't want a core that is so soft inside. And in order to lower the dielectric or increase the velocity, we would have to increase the dielectric constant. We're going to lower the density of this foam even more, and unfortunately it's going to collapse on us during wire dressing. In this case here, we've done an old school thing. We've gone to a copper foil. These are both techniques that are common to the RF world, old school, 50s, 60s, 70s. I mean, we're talking, as old as I am. But we realize now that at these higher frequencies, we are going to see leakage. We are going to induce noise into other adjacent cables, and we're going to receive noise. So we're going to improve propagation and loss by basically isolating the cable and improving its conductivity, since we can't improve its loss without making it bigger or softer. And unfortunately, soft will cost us. So in this case, this is a copper foil, not an aluminum foil, and a braid. If any of you are old Westpin schoolies, use a lot of Westpin wire. They did this years ago, and the RF world's done this many times. Matter of fact, we've done tri-layers, quad layers, many different techniques of shielding in the 18 gigahertz range to improve our test cables. So that's sort of the tidbit. I'd say Canare's got a mid-size and a full-size. This is an RG7. Belden's still doing its mini, mid, and full-size RG6. RG7, if you don't know the difference, is considerably different. That is an 1855 size at 0.159, and then we're out here at RG7, which has a 16-gauge solid center. We're just buying, some distance here on our runs, that's all. And along the lines of loss, I can pull out a chart and say, well, look, these are the numbers. But these numbers, again, will trick you into believing that you're going to get distances that aren't rational, because you can't tell me that RG6 works the same at 3 gigahertz as it does at 12 gigahertz. Well, it does if you quarter the clock speed, or you break it up into four 3G legs. So along the lines of how far you're going to get with this coax, well, that's really contingent upon how you're managing that signal, whether it's a single player, a dual player, or a three-leg, or a quad. So, and whether you're running at half clock speed, what your bit rates are. So read the tiny little getches at the bottom of these specifications and find out really what your equipment's doing. I get feedback from people who own different test gear about not being able to do mixed signals or mixed frame rates. No 29 point, it's either 30 or 60. They're not being able to play with this. No more 24 frame rates with certain encoders. So I can't speak for all these manufacturers and different equipment. So the other thing I'd like to talk about is size of connectors. There's the BNC, and there's the HD BNC that has become very popular. And HD does not mean high definition. It is high density. Look at the relationship here, okay? That's high density. This was designed and built by Amphenol. This is their baby initially. Yes, everybody makes one. I've got a King's here in my hand. I've got a Canare here in my hand. So I've got a real McCoy Amphenol. These are all the same connector. They all do the same job. I would say I lean a little more towards King's and Amphenol than I do the Canare, mostly because this is a little bit bulbous on the back end. And I like the Amphenol the best, is the coupling nut. It works very well with their tool. Now, keep in mind, these are just my opinions. The coupling nut has 2 notches in it that allow us to actually grab the bayonet mechanism and rotate it. I don't know if the camera's picking that up well, but there are 2 small teeth on the end of their tool that allow us to force rotate. The other tools sort of just grab the outside, old school design, and rotate. This actually has 2 points. I'm trying to get that to focus. So that actually grab the coupling nut and force the rotation. So there is an advantage to the original manufacturer because of those cutaways, whereas the other 2 manufacturers don't. The other thing that I'd like to bring up is DIN connectors. That's D-I-N, DIN. DIN is a push-pull connector we borrowed out of Europe initially. They look very much alike. This is a push-pull connector. This is 1.0/2.3. If you don't know anything about DIN connectors, DINs just refer to the ID-OD relationship. So all those weird numbers you see associated with DIN are actually the numbers associated with ID-OD, circumference of the mating interface. That's all. But 1.0/2.3 is a push-pull connector. The tool for it is radically different. It is nothing more than a hook. You just reach in and snatch that connector off. You snap it on, snatch it off. This will vary with manufacturer. There's some Chinese ones out there that I would steer clear of. We mated them to a PCI card and could not uncouple them. I don't know what was going on inside, but they were scary. And I can tell you this, we purchased some cards for a studio one time, and they first came with DENs. We bought the same part number, and it came with HDBNCs. That's high density. The other thing is, some people have been using the term mini BNCs. Trumpeter originally had a mini BNC. Trumpeter is the old school telecommunications division that set a lot of standards for broadcast simply by implementing it in the telecom world. There is a mini BNC back then. It existed on equipment. It was referred to as an MB. It was mostly 50 ohm. In some cases, it was 75. You'll see it on old Keithley equipment. So let's just set that connector aside and say that didn't come into the broadcast world. But Amphenol is actually producing a connector that exists between these two, and it is a mini BNC. I don't see it revolutionizing or taking over, but if you use the word mini BNC, somebody's going to try and sell you that. And if you really need the mini, M-I-N-I, BNC, it's a size between these two. I don't even have a sample of it. But if you Google Amphenol and mini BNC, you will see it. It's between these two sizes. It has a very rare occurrence. I don't see it taking off, but I didn't think this would take off either. So just to know that there are several different sizes here, and it is important to make the right purchase. The last thing you want to do is design around something budget-wise to find out that your $1 connectors and your $2 connectors are actually $5 to $6 a piece. It'll break the bank on you. Now, along the lines of receptacles, we've been fortunate that that infrastructure has not gone up considerably, nor have inline couplers and adapters. They've actually stayed reasonable. The other thing I'd like to discuss is tooling real quick. There's our basic old King's tool frame, interchangeable die system, get a die for damn near anything. Tool's big, hefty, expensive. These are very popular designs, originally put up by Paladin, which was bought by Greenlee, which was bought by somebody else, but everybody's familiar with the designs, relatively inexpensive dies. However, the big stuff, the RG6s, which is a specialty size, is still going to appear, and I have not seen proper tool dies for these frames yet that fit it. They're more like a 290 in the crimp. So these are 278, which was a popular size. So whereas the Neutrik crimp tool, this is a very popular Swedish design, very good tool, interchangeable die system, very ergonomic for crimpers, so really well thought out. So, and purchasable as a kit, of course. But the oddballs are not your minis and not your 59s, okay? Your oddballs are going to be your RG6s. They are actually physically different. Your tooling's not going to work unless you own the old school trumpeter tools that actually have 290 as a die system or relatively thereof. Both the Canares and the Neutriks are a little odd on their RG6s, so you're going to have to make a tool purchase in that capacity. Stripping, it's all over the place. You got old school Exolite designs. If anybody remembers, this baby pops apart. The drag it was adjustable by an Allen in the back, but 3-stage. In this case, this is a 2-stage or something I grabbed, and you get to adjust it to crimp down. Then you had the Paladin design that actually used rolling pins and adjustable by regular screwdrivers. So we got to adjust that with our greenie there, which was nice. And the rolling pins did a hell of a job. I'm still a big fan of this particular style of tool. You just got to get your spacing right based upon your connector. And that requires a little research, and I can't spoon feed everything to you. Then you've got your Canare. Canare actually takes a different approach. Canare actually is going to give you a tool based upon the coax. In other words, there'd be a 59, a mid-size, a full-size. They're 3s, they're 4s, they're 5s. The tool would be specific to the diameter of the cable. So versus this ones are fully adjustable. This one's got a tweak screw on it, but overall it's pre-configured, but there is some tweaking that you could do to it. Primarily, since it utilizes a stream relief on the side, you would actually, it's stuck with a particular cable group. Now, they all work the same pretty much. You stick a coax in it and you rotate it. So in this case, you hold the side and you rotate it. And the other ones, you do the same thing. You have rocker arms that come forward and you rotate it. I use a Schleiniger, which is a $20,000 pencil sharpener. We've had it for 25 years, actually, on two of them. But that's for big house. Now, not to say you couldn't buy one used on eBay or convince the company to drop $20,000 if you want, precision stripping. And that is the end all here. In other words, in order to meet performance specifications, you have to follow their directions. And their directions are going to say, don't do that. Their directions are going to tell you that too many cables bundled together is bad, and that bending tolerances are, they want sweeps, nice sweeps. They do not want right angle bends. If you go back and you look at your journals on CATs and how you can position and route CAT cable, especially CAT 6s and stuff, they dictate the installation process. And recently I've learned from one of our customers about some issues he's had with crossbleed between 6 gig or 12 gig and 3 gig. Is interference here, that they're picking up noise, but it's adjacent signals that don't belong. If you follow some old school techniques, one of them will tell you that certain cables shouldn't be run long distances next to one another, parallel. And another technique is don't run them perpendicular either. So, which is sort of a catch-22. You want to run them parallel, but you want to create space, and you don't want to run them perpendicular in short run. So, use your judgment there and research on it. Since the telecom industry has always led the broadcast industry, and they're miles ahead of us for data rates, I'd like to point out that they have transitioned mostly into fiber for their big long haul signals, and lowered their insertion loss and extended their distances using fiber, of course. But the other thing that they've become infrastructure of is this thing. This thing is copper. This is CAT. This is a CAT 6A. I see IP transitions in our future. I see us dumping all of our cameras onto a network and serving it up through the building. As soon as we've all got 25 or 40 gig backbones is a basic infrastructure, whether it be copper twisted pair or fiber. But I do believe that we're still going to plug in one coax or two coaxes into our cameras to receive these signals for a while, at least until I retire. So I'm going to pause it there because I can just keep running my mouth and see if anybody has any quick questions or would like to tell us about their personal experience, like we got from one customer running adjacent 12G and 3G signals parallel to one another and ending up with crosstalk. No.
Well, yeah, chat. Yeah. You know why? You know why when it's hot? Because the air is thinner. The plane doesn't get as much lift.
Anybody, you can unmute your mics. I don't know if we muted your mics. So
well, big difference trying to find the people still using.
No, everybody is able to talk.
The hotter it gets, the thinner the air gets, the less lift the plane has. So okay, so that's why. So
you should mute everybody and let the people unmute themselves because it's not gonna get crazy.
Scary. Okay, well, I'm sure. I'm sure.
Hey, Danny, this is Fernando at Midtown.
Howdy, Fernando.
Hey, Fernando, how are you?
Good, guys. I have a question. Do you see people wiring facilities 12G when they don't have the need for 12G just to future-proof them and run HD today?
So
what's your thought on that?
And I don't really want to carry a bunch of 12.
Keep in mind, there is somebody that is in the background that I hear audio, and it's completely blowing you away.
You need to mute everybody and let the people unmute themselves, the ones that want to talk.
Ben, can you mute everybody and unmute Oscar? Or not Oscar, Fernando?
Sure, I just did mute somebody.
I'm unmuted, so I'm okay.
Yeah, right, okay.
Matters.
We know why Fernando's here, because he's got a couple of cables he wants us to rush.
Oh.
Yeah. What was your question?
People that want to future-proof their facility and they don't have any need for 12G whatsoever, but they want to run 12G infrastructure today and run HD on it. What's your thought on that?
I'm going to say fiber. I'm going to say single mode fiber. I'm sorry. If I was going to do an editing suite or media rooms or something, I'd be dropping 12 fibers to each of them. Media rooms, I may limit that to a 4 fiber, but any place that is file sharing or server sharing, I'd drop 4 pieces or 12 pieces of glass. But if I had to use a coax, I would probably say RG6. I would say, stick with the stuff that's going to buy you that close to 100 meter kind of thing.
They're running wires to PTC locations. They are only, they're only HD now, and they want to do, future proof for 12G.
If you got the budget, I would drop a Cat 6. I'd drop an RG6, and I'd drop a 4 fiber. That's future proof to me. You could put anybody in that room and get anything.
And we can do all that in one jacket.
Yes, and then you could actually run a composite cable if you had to do it. I mean, we've done some crazy composite cables, everything you could think of in one jacket. But that, to me, that's future proofing because it gives you viable alternatives. The glass is not expensive. The copper is a given, and the cat is a given. So I think with those you would be safe. I expect, keep in mind, we can do more with the same coax. We're going to increase the compression ratio. Remember when we started out, we needed 4 coaxes to transport, then it was 2, then it was 1. It's the same way with H.265, H.264. It's the same way with a lot of the bandwidth. We allocated stuff that was never used, so we can compress the hell out of it. And narrow the bandwidth and increase our overall bit rate and frequencies for our specified needs. And like I said, if it's IP, if it ends up all basically getting dumped onto a network, then I would want a NIC card system, a network system that I could dump it on. And unfortunately, IT guys are still multi-mode, but you can get single mode stuff. I don't know that I would invest a lot in multi-mode unless the IT guys wanted it. In other words, I had a bunch of workstations. They were using some particular editing software, and they said, yes, we want to run CATs, but we want multi-mode. Then I would buy some OM4. And again, try and keep it as short as possible, because as soon as you say it's 250, 350 footage-wise, 350 feet-wise, all bets are off. None of this stuff's going to work. Just go fiber.
Okay, thank you.
Hey, Ben. Hey, Danny. Carl, Joseph.
Hey, Carl. Thanks for joining us, Carl.
Oh, I need some entertainment in the morning.
Sure.
Hey, one thing you kind of ran into a lot is this transition period when guys are bumping up to the higher gig rate on the cables is that they're still using crappy barrels. They're using the 3G barrels. There is a dielectric difference, and it gets to a point where sometimes they're using a 3G barrel and a 12G signal, and it's like, you add a foot or two, it'll work or not because the impedance bump changes, the reflections change. It was a little bit of a little period of training out there to tell these guys you can't do that. It's the barrel.
Oh yeah, we went through the same thing when they're pulling out their 50 ohm barrels and you're walking around going,
oh yeah,
let me try to show you why you're not getting a signal. You've got video cable with SDI and digital cable. In addition to that, you've got an arrangement of Radio Shack barrels in here that are 50 ohm, not even 75.
But you got a lot of people out there that collect barrels from different trucks and different jobs, and they just
that don't belong to them.
Exactly, and unfortunately, that's what ends up being in a line somewhere, and then they're like, "It's not working," and you go, "Where did the barrel come from?"
Yeah.
Oh, I had it from last time. No, you need to go to the truck, throw those away.
Yeah. That was another point I was trying to make is that if we're not going to earmark them, give them physical dimensional differences, write on them, do something. I think that Neutrik's approach to let's just change the whole damn color of it, quickly look at it, that's not our 12G spec, then it'd be advantageous. And I think that SMPTE should have gotten together with the manufacturers and said, we need a designation, a color designation, 3G, 6G, 12G, color or design, so that we can say from 10 feet away, that doesn't belong in this equation.
Yeah, we usually take a red marker and mark
There you
the
go.
barrel. Red.
Yes. No. Unfortunately, you'll be the only one. So now, other industry or other three-letter companies, we've actually color-coded the boots or color-coded the cable or something to say, this is our new version of the cable. You don't bring any of the black stuff with you anymore. It's only the orange banded cable. So don't even put it on the truck. No.
Yeah, very good point. Great. Anyone else have any questions or like to share an experience with us? Okay, well, we're pretty much out of time. I want to thank all of you for joining us today. This is, it's been a very, very challenging year, but hopefully we're all getting back to what it was before. Please feel free to call us, contact us at any time with any questions. We'd love to hear from you and look forward to seeing you all at, hopefully, what's going to be trade shows now.
Do you got time for a real quick question?
Sure.
Well, in those barrels, assuming you're buying a 12G barrel, what can you expect the loss to be? On a 12 gig signal, you barrel two cables together.
I actually couldn't tell you. In other words, I have not seen a published specification for insertion loss of a particular barrel.
I haven't either. So if you were to spitball it, half a dB.
Yeah, I would say half dB to a dB. So keep in mind, multiple matings of something. There, if you follow the automatic field, there's closed entry contacts. There is single slot contacts, okay, that open like this. There's quads that open as 4 fingers. So number of mating cycles is going to have a big impact upon the performance of it and how well it hangs onto that center. So everybody's got a slight difference design. I'm a big fan of closed entry contacts, but they're very expensive to manufacture, and I actually don't see them in the 75 ohm world, only in the 50 ohm world. But you've got your 2 split and you got your quad. So it's going to be number of mating cycles as well. But I haven't seen a published specification on it, no. And I don't own a 12G analyzer for 75 ohm.
Pretty much how good the plating is.
Yeah, plating is going to make a big difference, and beryllium copper is rather pricey. How it's machined, how it's crimped, and how it's cooked will say how many resilient times it will open and close, precision wise.
What would you say that? Just a rough guess. How many mating cycles would you say be enough to degrade that performance, say by like 2x?
5,000 or plus. Easy.
Okay.
2 years of rental use.
Yeah, I would say that's not a concern. What I would be more concerned about is unknown sources, cheap plating. I had some contacts that were female contacts. They were machined out of brass. They weren't beryllium copper. That means that they opened once and they stayed open. Single mating cycle test. Hey, they look good, and they stayed flowered. They machine those out of brass. It's okay to make a brass boy, but not a brass girl. That should be beryllium copper. But then tempering it and plating is such a factor. And if you closed entry contacts actually can be designed to touch more surface area. And that's an audio thing, meaning the more analog transference of physical contact. So, but it's a number of mating cycles. So
you can
good information. Thank you.
Yeah, if you had a fabrics or something, you can see it on the eye pattern. Even when you introduce a barrel or even bend the cable, you can actually see the eye start closing up.
Yeah, that isn't what I call a good indicator of performance, but not an actual measurement. So you got to drop about 30 grand in order to get a good picture these days. So, I played with a couple of leaders. They were decent for disconnect, but we actually never sat down and analyzed a single barrel. That's something I'm hoping to do in the near future. The problem is that if I get a bad result, I can't actually come on here and badmouth anybody because I'm only one source. Until 4 other people independently tested it, I would never make any claims whatsoever. I'm just not like that. Not here to sell you an idea or to dispel myths, yes, but not to badmouth anybody's stuff unless 4 other people independently test it. So.
All right, great. Thank you.
Yeah, by the way, you can reconnect that barrel 4 or 5 times to get different readings.
Yes, that is the other drawback. So, especially bayonet locking connectors.
For sure. Great. Thank you all again, everybody, and look forward to seeing you all soon.